Hey everyone, C+ guy here, back with another video. So let's talk about C-style arrays. So if you've been coding in C for any amount of time, you've had to deal with character arrays or char star arrays. And that's great. We want to print fixed strings to a console or maybe print some text out to a display, say in an embedded environment. But strings get more and more complicated with user interfaces. So printing a C-style array is easy. You set it up like this. Pretty straightforward. On the stack. This memory is on the stack. But what if you want to make it dynamic? Well, Mark, you can do it on a dynamic basis, like using malloc and reallocate. Now look at all this code right here. Who wants to deal with that crap? Use C++, use standard string, code all you want in C. Use the C++ compiler, and then replace your char stars and character arrays with standard string. Let's get into it. Okay, and we're back. So let's look at a simple example of two strings that we want to concatenate together. So we'll start with two words, hello world, and we're going to store them temporarily on the stack. We're going to concatenate them together and then store them permanently on the heap. And this is a common way of doing this when you're in the C environment. It is a little bit dangerous because you're using malloc. Now, if the string is going to be permanently left in memory, then it really is not that big of a deal. You just got to watch memory usage. But if you're going to malloc and put two large pieces of text together, you definitely want to do it on a heap. You don't want to blow all your stack frame. But you have to remember at the end to call free and to reclaim that memory. And that's the problem with this method. It has the potential of memory leaks. Now, good programmers are not going to do that, but it does happen. So we start with two strings. We then allocate on the heap based on the size of these strings, and we get the pointer to that location on the heap called result. And then we do some checking. We want to make sure there is no null pointer. And then we're going to use the string library. We're going to copy one string into the other. That's to get our constant temporary string copied into result. And then we're going to concatenate onto the same string. And, we get a final result of hello world. So it's rather cumbersome, although it's simple enough right now that it's not a big deal. Next, say we wanted to replace some text in that string in result and replace it with another. Let's say I wanted to replace hello with the word hi. And there's a couple of different ways to do it. In this example, I just directly put the two characters in there. We use string length again to verify size. And we do a mem move. And then we shift everything left. A little bit of math in there. We've all done this, and it works. So then at the end, we get hi world. Now, what's very dangerous about this, if we replace hello with something of the same size or smaller, we're good to go. What if we wanted to replace it with something bigger? It ain't gonna exactly work. We're gonna have to start allocating more memory and do more arithmetic. I'm not gonna get into that right now, but you get the point. And what a lot of people do is they just allocate a big chunk of memory that's going to be bigger than any size they ever need, which is wasteful. But you can do that, and a lot of people have done it. Now, if it's only temporary, fine. But then again, you got to do malloc and you got to do free. And if you do it on the stack, well, it depends on the system. If you're on an embedded system, you may only have 4 to 8K of stack frame space, kind of limited there. And Linux embedded environment, you could have up to 4 meg or 8 meg, I forget the exact number. But then you're okay there. We shouldn't have to worry about any of this. There has to be a better way. And still, even today, I see a lot of coding that looks like this. I want to point out again, we have to use free at the end. If we don't, we get a memory leak. And that's one of the biggest things people bitch about C is the memory leaks. Well, that's it right there, forgetting to put free. Especially in a loop or something recursive. Maybe only called once. Now you're relying on the operating system to reclaim that memory for you. What if you don't have that? What if you're using something that's using an RTOS? You may not get that memory back. Very dangerous. Again, in certain situations, if you know what you're doing, fine, and we can talk about smart pointers later, but for now I'm sticking with C to show why you would want to use some C++ semantics to get around this crap. All right, so let's take a look at how we would do this in C++. We will use the string class. It's part of the standard library. You would use the namespace standard to find it. And I create two strings, and then I immediately copy through the copy constructor. Get into that later. String 1 will be hello. String 2 will be world. So we have two strings sitting in two different objects. These are allocated on the heap. Very important to know this. You can have as many strings as you want in this function, and it's allocated on a heap. You're not going to interfere with your stack space. Now, there may be situations where you want to have stuff on a stack space. That's another time. That's another video. Now, to concatenate these together, we just simply use the plus operator, or we just, in layman's terms, we add the strings together, and we get a concatenated string with a final result, and we get hello world. And likewise, to do a replace, because string creates objects, standard string creates objects, we can look at result, and then we hit the type in the dot, and I'll show this later on my code example. Compare is an operation built into the class. And then there's different arguments you can use, but in this case, we start with 0, we have a length of 5, max we're gonna look at, and we look for hello. If it's equal, we'll get back a 0. If it's greater, we get 1. If it's less, we get -1. It's commonly used for sorting, however it works in this situation. And then if it does match, we just use the replace, and it puts high in there, and it automatically moves the memory around under the hood. And the big thing to remember about this, I can replace this with something bigger, and it will reallocate memory for me. You can do inserts and everything else. It's all done under the hood. And the best part is you don't have to worry about free at the end, because once it goes out of scope, the memory is reclaimed. You will hear this term thrown around quite a bit if you do any advanced C++ training. Bjarne Stroustrup, the inventor of C++, talks about it a lot. It's called RAII, and it's just a way of reclaiming memory once you get out of scope. All it means is once that object is no longer in scope, let's say you put it in a function, you leave the function, the destructor is called automatically, and these classes have built into their destructors free, or delete, the C++ version of free, but your memory is reclaimed. Bottom line is you don't have to worry about it. So you just use string for all of your character array needs, and you will be fine. And I'll even show you a way to make it backward compatible with your string library calls that you're very much familiar with, such as string compare and string length, stuff like that. So anyway, I'm going to set up Eclipse for this, and I will be right back. Okay, and we're back. Let's start with a string called hello world. I'm going to instantiate that into a variable called text_s, or text string. This is the copy constructor, and as I alluded to earlier, and kind of what it looks like is this. It uses the operator equals function, and that's how you make C++ behave this way, where you can use equals and plus signs and crazy notation that when you're coming from C, I'm like, wait a minute, am I adding numbers here, or am I adding string? How does this work? Well, this is how it works. When you do operator equals, it treats it like a function. And then you can pass in a string. Basic string is the underlying string. But you can pass in a regular string, or you could pass in char star, which is what is going on right here. And then it assigns it internally. If you want to go into it yourself, feel free to. There's plenty of documentation online about standard string. But that is what's going on under the hood. I created another string to kind of play around with, so you don't have to constantly work directly on strings inside of function arguments. So I created another one called word, which is the word we're going to look for, world. And let's step through the code. All right, now we can see that text s has been assigned a value. And if you go over here to the variables window, it has a length of 13, and you can see the hello world that's internal to this class, the instantiation of this class. And likewise for word s, the length of 5. One other thing I want you to understand, if you're coming from C, and you're dealing with standard string for the first time, or even if you have it and it's a review, the size is built in to the class. So it is always a property that you can get at any time. So for example, I broke that debug, just wanted to show you this. If I wanted to know the size of text s, we only need to do that. We instantiated it here, And then we can always get the size. This should be size T, which it is. You could also do it this way. Now let's get back to what we were doing before. So now that we have a phrase, inside of a string like this, let's say I want to find a word that's in there or a character. You can use the find method, and then it'll return by index where that starts. It says it's at position 7. Now, the way that find works, and it's a little awkward, but all the STL containers have a mechanism like this. When it searches, it starts at index 0. When it gets to the end and it doesn't find it, it's going to return what's called the end position, which is this constant right here. Position equals this. We know we searched past the end. So it's counterintuitive, but you'll get used to it. If position is not equal to the end position, then we found it. So we will step through this some further. And world was found at position 7. Now, just like in the earlier example, we want to change world to another phrase. In this case, I'm changing it to C++, starting at the position we found it, and we know the length is 5. Now, yes, it's hard-coded, but for this example, in fact, hold on, I'm going to change that. All right, I made a slight change. I made a replace string called C++. That way you can see how I can use the built-in size right here instead of hard-coded numbers. And we could pass in the string itself. All of these functions, by the way, are overloaded. There's usually, if you go through them, there'll be any combination of what you need to get done. So you can work directly on strings, standard strings, or you can work directly on char star arrays. And normally your IntelliSense, you'll be able to pick through the one you want. If you don't have that, or maybe you want to review it, just go to like Stack Exchange or cplus.com. There's plenty of documentation on the methods in this class. I'll put the link up at the end, but feel free to Google it and go through and learn standard string and all the capabilities that it has. I'm just giving you the basics to get going on this. So now if we step through the code here, we should see the replacement in there. And there it is. And now it says, hello, C++. Oh, look, we have a little bit of garbage here at the end. Can anybody see the mistake I made? I'll point it out. This was supposed to be the size of word S. So let's rerun that. And now we have the correct answer. But what's the takeaway here? Even when I made a mistake, it didn't crash. It allocated new memory. We just happened to see garbage text that was in that memory that it added that, didn't make any sense, but it did not crash. I think this kind of proves the point. Even when you make mistakes in C++, not all the time, but many times, simple ones like this, it just allocated more memory. Now, when it allocated more to the string and we printed to the end, we had some garbage in there, and that's what that mistake was. You can also do an insert. There's an insert. I'm going to step through it real quick. It inserted welcome at the beginning because we started at position 0. You can insert into it and it'll automatically grow the size of the array to what you need. And that's exactly what it did. In fact, the total size now is 20. So one final thing I want to show you is standard string is compatible with the older C functions. You can't access them directly because they're classes and it's C++. And if you're going to work with them with C functions want to see a pointer to a piece of memory or to where a character is in memory where the string starts. So one little trick that they give you is this method called cstring. I've been using printfs in all my examples to help people that are transitioning from C to C++, and printf is a perfect example of this. Even I still use printf a lot of times. Because I know all the codes and I know how to do it, and it's I can quickly print something out. Whereas cout, I don't know it like the back of my hand like I do printf. The formatter right here is the %s, which means string. Now, I can't just put text s in there because that's a string. It's going to print garbage. when you do try to print it, I will, right there, you see that garbage? It's pointing to a part of memory where the class was instantiated, not where the text is internally. You see dot, and look at it, we got all these methods that are available to us. So I'll start typing, and I know it's C string right there, it's at the top. It means treat it like a standard C style string, and what it does is, it's going to give you the pointer to the very beginning of the string that it has in memory, but it guarantees you a null terminator at the end, even if you don't put one in there. So you never have to worry about putting null terminators in ever again. And it would print out to the end like this. They have another function called data. There is supposed to be no null string at the end, but I think now they do guarantee it anyway in case you want it. So in practice, I use C string for when I'm working with C style strings. I know the null is going to be at the end, yada yada. Strings that are binary in nature, there's going to be some non-printable characters in the middle. I'll use data. That gives the person coming after you, like saying, hey, I'm using the string class, but I have non-printable characters in here. I have binary data, so I'm going to use data instead. You see it still prints out the same old way. There's plenty of resources out there for standard string, and C++com is a good one. It's a kind of a formal way of looking at the class and what operations it performs. And it does give some examples. So standard string, there's size, there's length. Length is an interesting one because length will actually give you the length of the string. It looks for the null character for you, which is kind of handy if it's not, it could not match the size, obviously. You can have the null before the size. You can resize the string. Capacity is how much memory is actually allocated versus what the actual size of the string is. All the STL containers have that. Clear basically zeroizes it out. You still have memory reserved, but the size just automatically goes to 0. It's really just moving a pointer. You can tell if a string is empty. It'll return true or false. And there's the C string operator I was telling you about. Data. You also have find. You can get substrings. End position, which is something I mentioned earlier also. They talk about some of the overloads, like such as operator, the plus operator where you can add two strings together. If we look at find, you have some examples down here. You just find the one you want. You're looking for a character, or you're looking for a string within a string. And that's kind of what I did on my example. There's your end position argument. And there's plenty of examples. And this is just one site. There's also compare, which is what I showed earlier. Also, you have erase. You can actually delete characters in your string and it'll resize it for you. Remember, all this is done automatically under the hood. All the ass pain with malloc and realloc and trying to track all that memory usage and that's all done automatically under the hood. It even has pushback, which is a container that's used for vector, and you could push back into this just like you do a container. There's so many things, and then if you look around, they have other things like string to integer, string to long. All this is built into this class. It's very powerful. Resize is a common function that's easy to use. Basically, it'll resize it and it'll just truncate the end of the string and just toss the garbage out. Kind of handy to have. Well, that's all I have. I hope you got something out of this. If you're coming from C and you're learning C++, standard string is your friend. I would use it every time you see a string, character string. You might as well just use this. It's compatible with so many different algorithms and searches. Probably the most common class that I use. There are other string classes out there that are useful, such as in the Boost library. Maybe someday I will talk about those. There's some Boost utilities that are quite handy for finding strings and doing replacements that are a little bit easier to use than what standard string offers. With that, if you like what I'm doing, I try to keep it informal and brief as possible and try to keep the videos short. I think you get the point when you watch these videos. So please give me a like and a subscribe. I'm trying to grow this channel. I'm trying to get more people out there educated that are engineers that work in C. Now, in my real world, in my real life, I do a lot of object-oriented stuff, but I came from C And in the embedded world, I have found that this style of this code style, or C-styled C++, is very useful, very practical, and very easy to read for people coming after you. So with that, I'm signing out. I'll see you on the next one.